Metric Mania Lesson 2 Volume. Make sure that you have your Lesson 2 Metric Mania Volume worksheet in front of you, as you will be filling it out as we go through this. Also remember that there will be some parts in which I will ask you to pause. Please pause the movie and complete the questions that are after. All right, so moving on, Lesson 2 Volume. Again, comparing English versus metric. As you already know the English, to try and get you used to the metric, we're going to have you compare. So answer the questions A, B, and C. Pause. So which is larger, 1 liter or 1 gallon? Definitely 1 gallon. 1 gallon equals essentially 3 3/4 liters. So 1 liter or 1 quart, they're actually about the same, but 1 quart is a little bit bigger. 1 quart equals 0.946 liters. And 1 fluid ounce is larger than 1 milliliter. 1 fluid ounce actually equals 29.573 milliliters. So if you take a look at 1 12-ounce can of soda, it would equal about 355 milliliters. So moving on to metric units. When we are measuring metric volume, we are going to be measuring that using liters. Okay, liters are the base unit for metric volume. You can represent a liter by either using a uppercase L or a lowercase l. And if you remember from the Bill Nye movie, he showed you that 1 liter is also equal to 1 cubic decimeter. Remember that box that he filled up with the blue water? That's what this picture is showing right there. One liter equals 1,000 milliliters. And you should remember that's the exact same thing as we learned when we were talking about meters. 1 meter would equal 1,000 millimeters. So all of those conversions are the same across the board. So moving on to the which is larger, take a look at the which is larger and answer questions A, B, and C. Pause. So which is larger, A, 1 liter or 1,500 milliliters? Definitely 1,500 milliliters. Question B, 200 milliliters or 1.2 liters? 1.2 liters. And question C, you had to refer up back to the 1 milliliter equals 1 cubic centimeter or 1 gram. So letter C is asking 12 cubic centimeters or 1.2 milliliters. And the answer is 12 cubic centimeters. Now on to measuring volume. We will be using something called a graduated cylinder to find the volume of liquids or other objects. When you are reading this, you need to read what is called the meniscus or the curve. So take a look at that arrow that points to the curve in that picture of the graduated cylinder. So when you are reading the meniscus, you always want to make sure that it is at eye level with you. Now, eye level with you does not mean that you pick it up off of the lab station and you hold it up in front of your eyes. No, 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 no. You need to keep the graduated cylinder on the counter and you need to bend over to make sure that you are at eye level. So again, when you're reading the meniscus, you want to make sure that you read the bottom of the curve. So if we were taking a look at the example on the left, what is the volume of water in that graduated cylinder, if we take a look, 40, 41, 42, the bottom is at 43 milliliters. And some of you may be wondering what causes the meniscus. The meniscus has that curve because the molecules of the water are actually attracted to the glass that are on the sides. So now we want to practice measuring using a graduated cylinder. Now, there is no meniscus on these, so we're just going to read it to get some practice on how it is to read these cylinders. So please make sure you pay attention to the scales. All of the scales on these cylinders are different. So why don't you answer A, B, and C? Pause. If you look at A, the answer to A is 52 milliliters. The answer to B is 37 milliliters. And the answer to C is 23 milliliters. Measuring solid volumes. We can either measure volume of a regular object, just like we actually did on the length lab, by doing length times width times height. Please calculate the length, width, and height. Calculate the volume of that box now. Pause. When measuring the volume of an irregular object, we want to use the water displacement method. So what we need to do there is take a graduated cylinder and fill it up with a certain amount of liquid. So for example, 200 milliliters. We want to drop the object into the water and we want to see how much the water raises. And then mark down how many milliliters that we have. So if we were to take a look at the cylinder to the right, we would see that it's probably at about 260 milliliters. We take the difference, so we take 260 minus 200, and we find out that the volume of that rock is 60 milliliters. I forgot to give you the answer to the cube above. All you need to do is multiply those two, so 9 times 8 is 72, times 10, our answer is 720 cubic centimeters.